Hello, everybody. I'm Ciprian Borodescu. I'm ex-founder and CEO at Morphle, a Romanian AI startup that got acquired by Algolia at the beginning of this year. I'm now head of Algolia Romania, and in my spare time, I'm also hosting a podcast called Get Your AI On, where I invite founders, entrepreneurs, business leaders, and even AI researchers to share their experience in dealing with problems that can be solved through intelligent use of data. For those of you that don't know, Algolia is an AI-powered search and discovery platform that enables companies of all sizes to deliver fast and relevant digital experiences that drive real results. And today we have over 10,000 customers, a community of over 400,000 developers, and we're powering more than 1.5 trillion searches conducted on the Algolia platform annually, which not many people know this, but it actually makes us 4 times bigger than Bing, Yahoo, DuckDuckGo, Baidu, and Yandex combined. When I joined Algolia at the beginning of this year, the headcount was around 300 people. We're now over 500 in less than 9 months, and personally, it was amazing to witness and contribute to this kind of growth. Now, in this presentation, I'm going to deconstruct the anatomy of an AI product, exploring what goes into building a performant AI system, describing the fundamental concepts and decision-making techniques we previously used at Morphle and now at Algolia. And in fact, we used it to launch Recommend, which is a brand new AI-based recommendation engine that empowers developers to drive business results. And we're using the same framework to launch new AI-driven initiatives and products in the following years. And of course, my hope is that you will be able to use the same framework. Now, just to set the expectations right, this is not a technical presentation, but it's not a marketing presentation either. In fact, the mindset I'd like to encourage during these 30 minutes together is looking at your e-commerce from an AI product perspective. And my hope is that by the end of this presentation, you'll have a better understanding of the following topics, the ones that you actually see on the agenda here. The AI product development lifecycle and how that's different from the conventional software development lifecycle, the anatomy of an AI product, and the associated 3-layer framework to identify what and how to build, launch, and grow an AI product as part of your e-commerce company or organization. And finally, the 5 behaviors of a cohesive AI and machine learning team. So we have a lot of things to cover, so let's just get started. So to better understand the AI product development lifecycle, let's look at the difference between conventional software products and AI products. Now, I think we all know that in the initial phases of conventional software development effort, the iterations are more feature-based. And each release adds more or extends software features. And the feature-based iterations continue until the software is at a maturity level that allows for version-based iterations. Essentially, we're in a true or false situation where a feature is either done or not done. And certainly this was the case when building Algolia Search from inception to delivery and support. And in the initial phases of the development, the founders developed the search engine, exposed it via the API. Then the dashboard was introduced, including the backend systems such as databases, security, and payment systems. Customers were not able to see any of it until the founders accomplished the development of the minimum necessary features, or as it is known in the ecosystem as the MVP, minimum viable product. And after that, Algolia Search entered a cyclic iteration process, and the team then expanded it to what it is today. And I bet this is the case with any software initiatives or projects that you might have in your company as well. Now, while this conventional software development methodology worked for Algolia Search, with the introduction of Algolia Recommend and other AI-first products we're building, we've stepped into a more nuanced approach to building AI products. We're no longer navigating a binary paradigm, true, false, done, or not done, when it comes to AI and machine learning models. Instead, we're dealing with a range, 0 to 1. And let me further explain this using Algolia Recommend as an example. So we understood from day one, and I'm guessing everybody understands nowadays what a recommendation engine is or is supposed to do. For us, the outcome was a list of frequently bought together related items and personalized recommendations to be displayed on a product detail page, which in this sense, satisfies the definition of done. However, the AI and machine learning component was the unknown in this case. How do we know when a machine learning model is done? That is the question. Is it when the accuracy hits 99%? Or is it good enough at 80%? And how do we measure that? Who's to tell whether some items that are being recommended are better than others? Now, clearly relying only on the subjective opinions of the marketers, or generally speaking, the team members, is not a good strategy. So fundamentally, machine learning modeling, AI in general, represents a search for that answer. And during this search, machine learning engineers iterate over different aspects of the AI solution, from infrastructure and frameworks to algorithms and models, seeking to find the best answer to the given problem. For example, at the lowest level, a machine learning training job iterates mostly over the same model continuously by changing the weights of the machine learning model. At one level above, a machine learning training job performs hyperparameter tuning, which is a way to iterate continually over the parameters of the algorithm rather than the weights of the model. For some customers, we might have training jobs running for minutes, while for others, it takes hours, depending on the volume of their data, the frameworks that are being used, and the infrastructure. Additionally, in the future, we might have machine learning training pipelines, which would iterate over multiple algorithms continuously to generate numerous models to choose from, and then perform hyperparameter tuning to find the best set of parameters. Hence, the performance of the models can vary a lot from customer to customer, and in fact, they do, as you'll see later in the presentation. This happens because there's one component, a critical component, where we do not have full control over, and that's customer data. And both quantity and quality are needed to be accounted for when building and measuring the performance of a machine learning model. Now, this might sound very, very complicated for a business mind. And let me tell you, this is actually complicated for a technical mind as well. But the reality is that these are well-known processes within AI-powered products. And the key is understanding the right trade-off between the investment required to achieve maximum accuracy and the benefits you can gain from using it. That's why, in reality, the AI product development lifecycle consists of an inner AI ML cycle represented by AI solution research and rapid experimentation, which are the activities and processes I mentioned above. Now that we have a better understanding of the different nuances between conventional software development and AI product development, we can dive deeper into the components of an AI product. Now, from an engineering point of view, to achieve the main goals for which it was built, the architecture of a machine learning system must be scalable. And from a business point of view, the AI product needs to add value to the customer and make sense commercially, obviously. Thus, there are a few layers needed to accomplish these goals. And the outer layer, which I'm going to describe right now, is the technical layer that consists of data sources. And I don't think it comes as a surprise that for a recommendation engine, there are two main data sources that can be taken into consideration: the product catalog items and user interactions like clicks, views, and transactions. And examples of data sources can be a CMS, such as Magento, Shopify, or WooCommerce, or Google Analytics, or any other third-party analytics platforms for user behavior signals such as page views, time on site, and conversions. The next component is the feature store. Now, one of the most important and time-consuming aspects of building machine learning models is data preparation, and specifically feature extraction or feature engineering. And according to industry studies, 80% of the data scientist's job is data preparation. And to address this tedious challenge in the machine learning lifecycle, the concept of a feature store was introduced. Basically, this is an interface between feature engineering and model development, kind of like a centralized data warehouse of features for data science teams to solve two issues. One, store large volumes of features in a centralized manner, allowing data science and machine learning engineers to reuse, experiment with, and productize machine learning models faster. And two, serve features at a low latency and high throughput to other applications and databases. The third component, machine learning models. Now, the basic models for a recommendation system work with two kinds of data like we've seen: user item interactions, such as ratings and buying behavior, and attribute information about users and items, such as textual profiles and even relevant keywords. Now, specifically for what we did in the initial versions of Algolia Recommend, we've used collaborative filtering-based algorithms. And some of you might know or might heard about it, but we're now experimenting in parallel with two new approaches to improve the metrics of our initial models. First one, matrix factorization using an implicit Python library, and another version, a model-based technique that has the advantage of being more scalable in terms of data set size and using additional features from items and users. And basically, this second approach is the one used also by Netflix. In the next year, the first part of the year, we're going to introduce another product called Predict, which consists of a family of machine learning models for predicting user intents in real time. These models are like shopping stage prediction, cart abandonment prediction, AA-based segmentations, and many, many more that will be added. The fourth component, obviously most of the time the output of a machine learning model is a prediction. And the key here is to identify where and how those predictions are actually being used. And in the case of a recommendation engine, the output is, like we've seen, a list of items with their associated scores. What we do with those predictions is key. In other words, the actions that the predictions enable you to take are the ones that deliver the commercial value and the main reason customers are paying you. Just to give you an example, for Algolia search customers, adding recommendations to their website is done with just a few lines of code. As you can see here, the frequently bought together recommendations are being displayed for their users, boosting revenue for marketplaces and e-commerce stores. The same steps apply when they want to include related products widget. And of course, since we are an API-first company, we empower developers to use Algolia Recommend API to embed those recommendations beyond the website, say email recommendations or any other channels. Now, given a set of recommendation algorithms, how well do they perform? How can you evaluate their relative effectiveness? What are the main KPIs you're looking to optimize? And what I've seen most customers do is to look at the conversion rate only. Now, obviously, everybody wants to increase their conversion rate, but knowing how a machine learning system can affect the secondary KPIs, such as average order value or click-through rate, can lead to increased revenue, even when the conversion rate hasn't changed at all. And we've seen this with the customers. And just to give you some local example, we all know Orange, Romania, they've used it and reported 8% more revenue coming from their out-of-stock product detail pages. Like I mentioned, we have over 10,000 customers, and those that are using search and recommend products do see their KPIs being improved like never before. And most of the time, this is the stage where A/B testing tells the real story. And it's used to test the efficiency of a machine learning system against the default solution, which may or may not be based on machine learning, or even against another machine learning system. And at Algolia, I can share that we've been, a lot of times we've been in a situation where we would test our own Algolia recommend product against, for example, Nosto. And this A/B testing, this is the most objective method with the caveat that the metrics are clear from the get-go and correctly measured, because you don't want to be in a situation where you compare apples with oranges. And the final step, there are two aspects that can be evaluated: the impact of the machine learning system with regards to the business commercial outcome, as we've just seen, and the machine learning model metrics. For example, in the case of Algolia Recommend, we're looking at the following model metrics: precision, coverage, mean reciprocal rank, recall, and F1 score. And I admit this is too technical, but I truly believe that a transparent system should at least inform even a marketer what's behind that black box they're buying. And of course, in my view, a marketer shouldn't just rely on a black box system. They should actually ask for these scores. Failing to do that, in my opinion, can even mean that there's in fact no AI or machine learning behind that platform. And you might not care as long as you're paying $50 per month for a recommendation engine. But if you really want to be serious about your AI and machine learning initiatives and follow the footsteps of big global brands that I can assure you they are doing it, or at least learn from them, you do need to pay attention to these details and work with your provider or providers the ones that care about what's important to you and are transparent about how they're doing things. And I previously mentioned that the performance of the models can vary a lot from company to company, as you can see here. We have to remind ourselves that both data quantity and quality metrics influence the model predictions. And there's a saying in the data science world, machine learning world, that garbage in, garbage out. So again, it's really, really important to have data quantity and quality. Now, that's all about the outer layer of the framework. Moving on to the middle layer of the framework, we have the business layer that consists of the following components, which we've used before launching Algolia, our own Algolia Recommend, to assess the business opportunity. And I believe you can do the same for your AI initiative. So the first one is mission. For us, the mission was to boost revenue for our existing e-commerce customers via a flexible recommendation API. Second, goals. We launched Algolia Recommend in beta in April this year. And one of the goals back then was during beta to get enough customer adoption to be able to do the general release in June. Now, the overarching goal is to be able to scale the infrastructure to billions of recommendation requests a month. Number 3, persona. You might have one or more personas that you're working with. In our case, we have buyers and users. Buyers can be the tech decision makers, in our case, the CTOs or the CMOs. And on the other hand, we have users that are the developers. You also have use cases. And this is where it's important. What is the problem we're trying to solve? What is it that we're actually building it for? This is where the definition of the use case comes in. And for us, it was pretty straightforward. We decided that we're going to have for beta just these 2 use cases, frequently bought together and related products. Others to be added in the future based on customer feedback. And finally, success metrics. I cannot stress enough how important success metrics are, especially when building an AI product. Depending on the size of the company and the maturity of the product, success metrics, they do vary a lot. But usually when launching a product, what you want to measure is the adoption rate. And if there's any value, if there's any dollar attached to the product, the revenue. I would not add more than 3 main success metrics at this stage. Otherwise, you risk losing focus and what's important for the product. Now, at the core of any AI product sits the value on which the company has been built, and that guides all the product decision we're making. And here's a list of core values to inspire you via Dare to Lead by Brené Brown that you can use as inspiration when defining your own core values as an individual, as a team, as an agency, or as a company. Now, at Algolia, for example, we have grit, trust, care, candor, and humility as core values. And while values are internal, ethics, and in this context, AI ethics is external facing. And ethics, you can think about it as the manifestation of your core values throughout the products and services you're providing to the external world. Now, there you have it. I've presented these layers from the outside in, but in reality, in practice, we're building AI products from the inside out, starting from the core values, building the business case, and finally developing the AI product. The last point I want to leave you and I want to share with you today is the AI team. And of course, we cannot talk about the anatomy of an AI product without talking about the AI team that's actually building it. And there are two cultures, and I think this is one of the main things that you need to understand about this point. There are two cultures of structuring an AI machine learning team, depending on the type of organization you are or you want to be. First, one school of thought dictates that a machine learning team should consist of data scientists who collaborate closely with software engineers. This creates a team culture where software engineers don't need to have deep expertise in machine learning, but they have to understand the vocabulary of their fellow data scientists. The other option, the other school of thought is for all engineers in a machine learning team to have a combination of machine learning and software engineering skills. Of course, there are pros and cons in each culture, and depending on your organization, one is better suited than the other. Or depending on the stage of your company, one option might be better suited than the other. I can share what's our culture at Algolia. We're favoring machine learning engineers that have a combination of machine learning and software engineering skills, which is not to say that we do not have value or hire data scientists with an applied research mindset. So finally, there are 5 behaviors that I believe any team should have, and this applies to all kinds of teams, not only AI and machine learning teams. And that is trust, creative conflict, not just conflict, commitment, accountability, and results. More on this topic in an episode that I published a few months ago on getyouraion.com, where Thomas Gerber, ex-director engineering at Salesforce Einstein, discussed all 5 behaviors or dysfunctions, depending on the angle you want to put on it, and how these apply to AI and machine learning teams. And finally, the topic of this presentation has been brewing in my mind for some time now, and I've been researching and working on these concepts and frameworks since the beginning of this year. I've been drawing from my experience building Morphle for 3 years. The launch of Algolia Recommend and the next products, AI products that we're going to build, and taking inspiration from books such as these ones right here, which I recommend to you. Connected to this topic, I've also written a series of blog posts, 4 of which are already published on our blog. And I invite those of you who are interested in this matter to give it a read. And you'll find in there some of the notions that we've touched on today. Finally, thank you for giving me the opportunity to present the topic that I'm passionate about, which is building AI products. I hope this was useful to you in more ways than one. And if you have any questions or suggestions, you can reach out to me on LinkedIn, on Twitter. You also have there my email address. Thank you, and let's make AI happen together.
Thank you, Ciprian, for your presentation. At least for me, it was quite inspiring to understand the backstage of what happens or what's actually the primordial soup when considering doing a machine learning AI model. It certainly helps, I think, anyone who tries to understand how do you even start considering such a product to develop or to conceive. And most of it, what I've seen is that quite different from other solution providers based on similarity of functionalities. Your approach is rather human approached towards AI, and I think that's something that, or at least I haven't seen in anyone else's presentations or details about what's actually happening before you consider to do that. And I'm quite confident that at least in your case and building these prediction models that you start, as you mentioned, outside in and then inside out, it really helps you understand from all sides. You're actually on the both sides of the fence and trying to build the fence itself so that you are really aware of what's happening on both sides. So I was quite curious to understand more, and thank you for your presentation. If there are any questions regarding the presentation that you can, feel free to ask. I have a question though regarding the fact that we have merchants, we have people that are e-commerce managers, or people that really want to enhance their e-commerce experience by providing their clients a search feature, and there are a lot of them out there, as you mentioned. What should they consider when they approach? Of course, pricing is a topic which is quite sensitive in most cases, but outside that, what is I would say the main advantage of a solution like Egolia when considering on the short list of solutions for the e-commerce store?
So I think just to get pricing out of the picture or out of the conversation, a lot of platforms, including Algolia, offer a free tier. So at least you can try it out. There's nothing really you can miss by doing that. The other thing is like most users that do search are more likely to convert. We know this, and these are the studies. And so if search is something like 3%, 5%, 10% on your website, you need to pay attention to that aspect of your website. And gone are the days when just including a search bar on your website finishes it's a checkbox, it's done, search is done. It's not like that, because if your users are actually spending time there, you do want to surface the most relevant products that they are searching for. And so I would approach this from a data-driven mindset. I would look at the data that I have as an e-commerce to see how search is used first, and then I would simply A/B test with the search that I have today versus a search provider, whatever that is, Algolia or another, and test. And of course, take the decision or make the decision based on what the A/B tests and what the numbers show you. I think this is the most objective way of looking at things.
Fair enough. So there you have it, folks. Really happy again to have you here, Ciprian. Thank you for sharing your thoughts on this topic.